All right, everyone. We're going to go ahead and get started here. So thanks again today for coming to the XR Creators Unite event. So really excited today to introduce our speaker, Federico Marino. He's a computer science engineer and a faculty member at the University of Buenos Aires. He specializes in computer graphics, visual arts. He's also an independent software developer at Idiomatic. I don't know how you have the time, man. I can barely keep my job and this stuff going. So kudos to you, right? So he specializes in development of 3D apps, really interested in experimenting with new ways of combining technology and art. Last year he presented a piece of software called Lumicles VR, which is a really cool web VR audio-visual experience. It really takes the GPU particles to the limits. So if you could welcome Federico today in a normal XR creators fashion with a bunch of welcoming emojis, that would be great. And it's all yours, man.
Okay. Thank you, John, for the introduction, and thank you all for coming. And I'll start with the presentation. Well, first, let me tell you a little bit about me. Well, John said much of it, but I'm a computer science engineer. I work as an independent software developer. I'm specialized in 3D graphics. Since 2007, I've been working as a teacher of computer graphics at the University of Buenos Aires. And I love to explore ways to combine art and technology. I think today that today, with the number of tools and platforms available for VR development, there is a huge amount of unexplored possibilities to do. So first, let me define some terms before going to the main subject of this presentation. What is generative art? Well, it refers to art that is made totally or partially by an autonomous system, and that is able to determine features of the art piece that could be otherwise determined by the artist. You could say that generative art system takes the role of a creator. This concept exceeds the boundaries of digital art, and there are examples of generative art based on mechanical systems or even simpler. For example, the idea of writing down a set of instructions on a piece of paper and making someone execute them could be considered as generative art. Then we have creative coding, which is a type of programming that aims to produce something expressive instead of something functional. And some examples of this type of programming are live visuals, data visualizations, art installations, projection mapping, or even sound art. Then let me talk about Three.js, which is a JavaScript library I use a lot for my projects and enables you to draw 3D graphics inside the web page. It's an open source project that has been around for many years and has an active community of developers behind it, with lots of examples and good documentation. It's based on WebGL and uses the power of the GPU to render 3D graphics very efficiently. Then WebVR is the first standard that enables the use of VR from the web browser. On the other hand, WebXR is the new standard that replaces WebVR and adds support for augmented reality inside the browser in mobile devices. WebXR is still under development, but right now can be used in Firefox and Chrome. Finally, I'm going to talk about the Lumicles VR project. This is a project I've done in collaboration with another artist called Esteban Gonzalez. He composed some experimental music a few years ago and came to me with the idea of developing visuals for his music. And after many months of experimenting, I got some interesting results with particle simulations, which finally resulted in Lumicles VR. This project was programmed in JavaScript and WebGL, and I also used React.js to build the user interface and many other libraries to handle sound and music. Here's a short video showing the main features of the application. So I hope you all have seen the end of the video. There are perhaps some delay issues. I will move to the next slide. So this project was presented at the National Art and Technology Contest here in Argentina in 2018. And in 2019, it was selected among other 20 other projects for an exhibition at the CCK Center in Buenos Aires. And the exhibition was open to the public for free and lasted about 3 months. I had the opportunity to see the users' reaction at first hand, and some of them got really engaged with the experience and stayed up to 25 minutes in VR. And here you can see a picture of the installation, and I used a DK2 Oculus and a PC gamepad as a controller. So let me talk now about the main concepts that drive the simulations. Vector fields can be thought as arrows in 3D space that point where a particle should move in the next short period of time. So in every frame, each particle position gets updated based on the computed vector field. Initially, the particles are organized in this, what I call distributions in 3D space, and the particles can be forced to move to these distributions at any time by the user. Then the vector field takes control of the motion of the particles as the simulation develops. Now some technical details. At the core of the simulator, there are shader programs that are written in GLSL language, and they compute the vector fields, and they use the location of the particle and the current time of the simulation as inputs to update the position of the particles. Here you can see an example of these shaders. They are very, very short, very simple programs. Another key ingredient in the simulations is Perlin Noise, which adds some distortions to the vector fields to generate this organic view you see in the images. Now let's talk about the rendering process. Each particle uses 3 numbers to store the XYZ coordinates and a 4th number to represent the index in a color gradient you see here on the right side. So the state of each particle is represented only by 4 numbers. The renderer draws each particle as a 2D rectangle. Inside that rectangle, it draws a translucent circle with blurred edges painted with the color of the particle. The final image is obtained by overlaying millions of these rectangles on a screen in every frame. The simulation is also computed by the GPU using a technique called texture ping-pong. The state of each particle is stored in the pixels of the textures. And you can see here, a shader takes the input texture and updates the result in the output texture. So all the simulation is carried out by applying a filter on a texture. Then the application also can be used as a desktop app and has a 2D menu where you can control every aspect of the simulation. There are also many types of cameras you can use, and you can control them with a keyboard or the gamepad. Then for VR mode, there is also an interface, a user interface, that is accessible through the gamepad and is a sort of dashboard in front of you where you can access the same menu you see in the desktop version, and you can move around in the menu and use the thumbsticks to control each of the sliders that handle the simulation. Here is a short video showing how it works in VR mode. Sorry for the quality of the video. This is due to the compression of YouTube. You are free to move around in all axes in 3D here using the gamepad. All right, so this is the end of the video. Let's move to the next one. So usually the rendering process in WebGL uses 8 bits to store the RGB colors or RGB values of each pixel on a frame. In order to add the contribution of thousands of particles on each pixel, 8 bits is not enough. You need to use 32 bits instead to get this smooth result you see in the images. So the rendering process is carried out in a 32-bit buffer, and then after some post-processing steps, the frames are converted back to 8 bits. That's one key issue to have in mind. Then we have depth of field effect that can be easily achieved by controlling the blur of the circles that represent each particle depending on the distance to the camera. Here you can see 3 examples of the focal plane at different distances from the viewer. So when the circles are near the focal plane, they seem to be sharp, and they are blurred when they are too far away. Another important issue with the result from blending millions of particles is that you get some sub-exposed areas of the image, and on other parts you get overexposure. So to fix that, I have to develop a post-processing filter that dynamically corrects the brightness of the pixels and equalize it over all the image. On the left side, you see the uncorrected version, the render output, and on the right side, you see the result after applying the color correction filter. Another effect you get for free after applying this color correction filter, because it requires a blurred version of the image, is this bloom effect. Here you can see an example of different intensities of bloom effect. You can control that intensity from the main menu. And this is the complete picture of all the stages of the rendering process. First, you have the particle simulation, then the 3D view is rendered, then a blurred version of the image is generated, and using that information, the final correction and the bloom effect are applied. This is another video showing more of the scenes that can be generated with the simulator. Most of the videos use between 1 million and 4 million particles. You can check out longer versions of these videos at my YouTube channel if you want. A lot of people ask me if it's possible to run this simulation on mobile devices, but unfortunately, mobile GPUs are not that powerful yet. This is run on a GTX 1070, and you require a quite powerful GPU to use it. There are an infinite number of combinations you can get with the simulator, even though I only program about 20 different types of vector fields. So you can spend hours and always see a different result. So that's it for the video. Let's move to the next one. So I haven't talked about the sound system. The sound system has a specific set of pre-recorded audio tracks associated with each type of vector field, which were designed by this other artist, Esteban Gonzalez. He made all the music on all the tracks. What I did was build a program that controls those tracks in real time. Some are looped, some are triggered by a specific event, and the system controls the volume, the playback rate, and the 3D position of the audio in virtual space in real time, and make changes depending on the user location, the view direction, and the current simulation parameters. It also applies low pass filter and high pass filters to the music. And the final sound composition depends a lot on where you are in 3D space inside the cloud, and which is the current dynamic of the simulation. Now, here you have a gallery of snapshots I took. The system also allows you to make very high resolution captures. To do that, what I did is, because WebGL doesn't allow you to do a huge image in real time and render. So what I did is, when you pause the simulation, you can take a snapshot of a slice of the image, and once it finishes, it takes about a minute or two. I do a server-side process to merge all together to get a very, very high-resolution image. I got up to, I think, 8,000 pixels wide images. There are a lot more of these images in my personal web page. So finally, I have these interesting results I found after playing around a lot with the simulator. And there is a concept called Emergent phenomenon, where a couple of simple low-level rules combined generate complex behavior at the higher level. And I think these images could be a good example of that. They seem to have complex structures, but the program that drive the simulations are pretty simple. But even though these seem to be some sort of organic creature, they look like biological entities. So that's all for now. I hope you like the presentation.
That was awesome, Federico. Thank you very much. Those pictures are, whew, there's something
Thank
else.
you.
So,
Okay.
Federico, you said you guys were basically using and storing the information to a 2D texture image.
Yes.
What did you have limitations in the space? Did you bound it into some known volume ahead of time, or did you just let the particles go from there?
No, you have a limitation of the number of particles you can store in a texture because there is a limit of resolution in WebGL, but there is no boundary of the values you can store about the particles, so they can move in a theoretical infinite bound. But you store a floating point number, and it has some limitations due to the precision. But you could think that they can move freely.
Very cool. And I'm assuming the limitations with getting it on mobile is primarily because of WebGL.
Yes, not really WebGL, because WebGL, what I use from WebGL, the requirements are very low. I don't use any special feature that is not present in WebGL 1.0, but the issue is the power of the GPU. To get this smooth-looking result of these images, you have to simulate at least 1 million particles in real time. If you go below that, you get something not very interesting.
Thanks a lot, man. We appreciate this. And
Thank
the stuff
you
is
very
like
much.
visually extremely looks great, like beautiful stuff. So
yeah, you can spend hours inside VR experiencing it. A lot of people told me that they would like to have that at home to do meditation or for relaxing.
Yeah.
Yeah.
Cool. Yeah, very mesmerizing. I really enjoyed that.
Yeah, I think that well, this is just I didn't have time to experiment what I wanted to, but because we presented this at this contest, and we have very limited amount of time to finish the project. But I hope one day I have time to do, I don't know, perhaps 100 of more different effects, because there are so many things you could do differently. So I don't know, perhaps there are more interesting dynamics you could get. Just explore a little the tip of the iceberg.
I had another question as you're talking about that, Federico. Because you're just storing the information to a texture, could you build another system that would dump data there? So could I turn that into a pretty quick particle visualization system without running your simulator? Just say I had some other system dumping data.
Yes, you could. But the thing is that one problem is if you want to, for example, send data to the GPU from the CPU for a standard program, there is a bottleneck there because the transfer speed is very slow compared to the memory access of the GPU. So this works in real time because the simulation is carried out inside the GPU.
Gotcha.
But if you can compute your dynamics inside the GPU, well, yes, you can use it for visualization.
Gotcha. Yeah, I totally forgot about the handoff of the data there.
Yeah. No, not really, because well, in the exhibition, many people that were perhaps
Sorry, could
Yes.
you repeat what he had said? Because I don't know if everybody could hear what he was saying.
Oh, she asked me if I had approached someone with the interest of using this for, I don't know, some medical application or for, I don't know, relaxation or any other application not related to art. That's what I heard. Not very well, but and not really because, well, during the exhibition, many people asked me how it worked, and they show interest, perhaps in using it on any other application different than art. But yes, sure, I think it could be used for many applications.
Sorry, I didn't notice I was standing back there and my voice was too
Okay.
tiny. I apologize.
Okay.
Thanks for that.
But I understood the basic idea.
Mm-hmm. Perfect. Thank you.
Cool. Nice. Anybody want to hop up on the stage for a picture? Might as well.
Yeah, let's do it.
¿Qué sucede?
And if somebody has a front-facing camera and wants to take a photo for us, that would be cool. I don't think my bot's
Yeah, I
gonna
don't.
grab a
The
photo.
setup, they got rid of the camera mode on this one with the if you're not in VR now.
Oh man, are you serious?
Yeah, it's all selfie mode. Yep. Oh no, they took it back. Okay, good. They must have fixed that in the update.
All right, let me see if my camera's.
It's a one floating in the air.
All right, everybody, throw up some emojis. Get up on the stage too if you want to be.
Okay.
Because the camera's only covering the stage right now. Awesome. Hey, fella, thanks for coming by.
All right.
They just fall off.